Well, today I want to take you through a few examples of making conversions using various amounts that are related to the mole. So on the screen here you see the three sort of constant relationships we use when making mole conversions. The first is using Avogadro's number, which is 6.02 times 10 to the 23rd particles. It's a big number we talked about as the number of particles that it takes to have a mass in grams equal to that substance's mass in AMUs when we talk about a single atom or molecule or formula unit. So see your earlier notes on that again. But 1 mole of any substance contains 6.02 times 10 to the 23rd particles. The second is that 1 mole of any substance, whatever substance that might be, has a particular unique formula mass all its own, a molar mass, if you will. And that mass is the one that we get from the periodic table by adding up the atomic masses for all the atoms in the compound. And we've been practicing that already, so hopefully you feel pretty good about going to the periodic table and adding those up. The third is that 1 mole of any gas has the same molar volume, 22.4 liters, assuming we're at constant standard temperature and pressure. And the standard temperature and pressure values can be all kinds of things depending on which scale you're using. But for now, as I've told you in class, we're going to work for the time being, assuming that we're always working at standard temperature and pressure conditions. Later in the year, we'll move on to problems that involve other temperature and pressure conditions that aren't standard. For now, you can assume that always 1 mole of any gas is 22.4 liters. So what we're going to practice on these next couple of videos is making conversions between various units that involve the mole as sort of the center hub of a three-pronged wheel here. One is for particles, one for grams and mass, and one for volume in liters. The ones that we use most in stoichiometry problems in everyday chemistry probably have to do with grams and liters, and less so with particles, so we'll practice fewer with those, just because they're not so much practical every day. Hopefully you have a worksheet from me that involves the mole conversion practice problems. I think there's 20 or 30 on this page, quite a few. And what we're going to work on here are some examples of conversions going through some of the select problems that are on that page. I've chosen some various things that we're going to use the mole conversions to do. And so we'll start out with this one. So to get started with this one, what you want to work from then is the number that you're given at the beginning of each of these problems, and then continue on to work with the values from one of those three constants, again using either grams or particles or liters. I'm going to turn on my pen here in blue, so hopefully you can see that fairly well on your screen, especially if you're not looking at it on a phone. But in any case, we start out with the number that we're given here, 985 grams of sodium chloride, and the problem is asking you to convert this then to moles. So you want to start with whatever amount you're given, as the instructions say here. Start always with the value you're given in the upper left corner. And I make these little T boxes kind of to organize the numbers and keep the values in the numerator and denominator straight. So I'm going to put 985 grams of sodium chloride in here. And then the next box, then it says add quantities that are equal to each other in the numerator and denominator so that the units will cancel out and leave you what you need. In other words, I'm trying to get rid of grams and I'm trying to get to moles. So since I'm trying to get moles, I need to put that on the top, and the grams should go on the bottom. Now, based on our previous information there, we know that 1 mole of sodium chloride has a particular mass that we can add up off of the periodic table, and that's what we'll be asked to do here. But in the meantime, I need to know that 1 mole, and that's going to go on top then, of sodium chloride contains some number of grams of sodium chloride, again from the periodic table. Now this is one that you've already added up, so if you check your previous page and you're in my class, then you'll find that number's already there. If not, you can go to the periodic table and add up sodium and chlorine's atomic masses, average atomic masses, and usually 1 or 2 decimal places is enough for this kind of work, otherwise the precision just gets to be really cumbersome. So if we look them up, sodium again is about 23 grams, and chlorine is about 35.5 or so grams, depending on your periodic table. So we put those together into this box, and that gives us 58.5 grams of sodium chloride in any 1 mole of sodium chloride. Okay? So as we go to the periodic table and add those up, be very careful that you add up exactly the elements that you're being given. And when I put this into my little t, then I'll multiply across the top and divide on the bottom. So the grams of sodium chloride then will cancel out, just as in math class, x over x would cancel out, grams over grams cancel out, and I'm left then to do the math from there. And when we punch that into our calculator, we should get an answer of somewhere around 16.8 moles. So when you divide that out again, 985 divided by 58.5, you should find something in the neighborhood with rounding and significant figures. Sometimes the answers come out a little bit different, but something really close to 16.8 moles. And so you want to record your answer there. And make sure when you're labeling on your conversions that you use a unit like moles, grams, or liters, or particles, and that you use the substance that's in question. In this case, that's sodium chloride. So 16.8 moles would be a good answer. So that's pretty much the idea. We organize it by starting with whatever number you're given in the top left corner, and then in the next set of boxes we put in some kind of equality statement. 1 mole of sodium chloride is equal to 58.5 grams of sodium chloride. And it would be the same either way if I put it in there. It'd be true upside down and right side up. But since we want grams to cancel out, we put the grams, our starting unit of grams, on the bottom so that you'd have one on the top and one on the bottom, and they would cancel each other out, leaving you just with moles as your final unit. And 1 mole of sodium chloride contains, as we added it up, 58.5 grams. Let's look at another one. This is number 3, and it says 2.50 moles of NO2. We want to convert that to grams. So again, I'm going to start with 2.5 moles of NO2 in the top left corner, and I want to convert that to grams. Now again, I need a mole to gram equality statement. 1 mole of NO2 contains how many grams of NO2? Now last time we put the moles on the top because we wanted to get to moles. This time we are starting with moles, so we want to get rid of that unit. And so I'm going to put my 1 mole, and you'll find when you're doing conversions that allows to be 1 mole of something. 1 mole of NO2 contains how many grams? Well, as it tells you here in the hint at the top, you'll need to add up NO2 if you haven't already done so, and I think that was on our practice page as well. And if you add that up, you should find that 2 oxygens and a nitrogen make about 46 grams, so 46.0 grams of NO2. And again, if you're not quite sure how we're getting that, NO2 is an N plus 2 O's. Well, N is 14 grams per mole, and oxygen, 2 of those, are each 16 grams per mole. And when we add that all up, that's N, this is N, plus 2 O's. Okay, and that makes 46 grams. So 2.5 moles times 46 grams per 1 mole. And what I'll do is cancel out my moles. Those will disappear. And I'll just multiply across the top. Now, on number 3, when you multiply, the calculator is going to tell you 115 grams of NO2. And that's an okay answer. But if you're real good at significant figures, and you think back to when we did significant figures to start the year, you know that by multiplying 2.5 times 46.0, the 1 on the bottom is sort of a constant, so you don't need to think about having significant figures down there. But 2.5 moles times 46 grams, we would only be able to have 2 significant figures in our answer. So a better answer would be 120 if I rounded that off, 120 grams of NO2. So for now, again, as we're warming back up to significant figures after some time away, either answer would be okay. Just know that eventually I'm going to work you back toward focusing very intently on using significant figures. So 2.5 moles times 46 grams per 1 mole gives us 115 grams of NO2. Let's look at another conversion. This is number 7 on the same sheet. And if you don't have the worksheet that I'm giving you because you've forgotten it, or you're not in my class and you're watching this for the heck of it, then you can make a conversion like this in any scrap piece of paper. So 6 moles of krypton. I have 6.0 moles of krypton. That's a gas. So we're going to convert it to liters of krypton gas. Now recall again, Avogadro's gas constant is 22.4 liters of any gas for 1 mole of that gas. So in this case, well, that's going to be our equality statement, but what goes in the top and what goes in the bottom? This is where students often struggle. But again, I'm given moles at the top of my first part of my conversion here, so moles need to come down here, and specifically, as I said before, you'll pretty much always have 1 mole of something. In this case, 1 mole of krypton is equal to some number of liters. Again, liters the unit that we want to get to. Well, again, according to Avogadro's gas constant, 1 mole of any gas is 22.4 liters. So there's that number we're going to use, 22.4 liters of krypton in 1 mole of krypton at standard temperature and pressure conditions. And so for this, we'll take 6 moles times 22.4 liters per 1 mole, and the moles will cancel out when we divide. And so in the end, 6 times 22.4 gives us 134.4 liters of krypton. And again, if you're following significant figures, a better answer in terms of sig figs would be 130 liters of krypton. And again, no decimal point there like in the last one to give us two significant figures. Again, either one for now would be okay, and we'll work toward being very good at sig figs again. So that's three examples of conversions using moles or moles and grams, or moles and liters. Let's look at another one. We've got number 9 here. This is 456 liters of sulfur dioxide. So again, we're going to start with 456 liters as my given and put that in the top left corner. And again, as the instructions say here, you need to get to moles of SO2. So in order to put moles in the final answer, we want to put moles on the top. In this case, 1 mole of SO2 is equal to that same 22.4 liters we used in the last problem. Again, notice though, in the last problem, we put liters over moles because we wanted to get to liters. On this problem, we're going to put liters under moles because we want the liters to cancel out. 22.4 liters of SO2 per 1 mole of SO2. And when I do my math, liters are on the top in my numerator to start out with, and my liters rather, are in the bottom in the denominator. So they'll cancel out. Liters cancel out with liters. Okay, you can X those out or however you want to do it. 456 times 1 divided by 22.4. All right. So when we do that, we basically take 456 divided by 22.4, and our answer should come out somewhere right around 20.4 moles of SO2. And again, look how I'm being very deliberate to have a quantity, 20.4, a label, moles, and a substance, SO2. You want to sort of have that 3-part answer as you go through these. So we've done 4 examples now. We've converted from, go back to the beginning here, grams to moles, that was number 1. From moles to grams, so we flipped our kind of constant over and the moles went on the bottom. Then we converted from moles to liters, so liters were on the top and moles on the bottom. And then finally at the last one, moles were being converted from liters to moles here, so liters go on the bottom so that they cancel out, and moles on the top. Now, any conversion you see on your practice page from me, or any mole conversion that you see anywhere, where you're either given moles or asked to convert to moles, should be able to be done in one step like this, just one step. And so if you want to look around the page and kind of choose the ones, at least for now, that have moles given or are asking you to find moles at the end, you should be able to do all of those in one step. There are some others on there that involve working with 2 steps and working with grams to start out with and liters at the end, or liters to start out with and molecules at the end. Those are 2-step conversions, and you'll see those in the next video. But for now, I would recommend you go around, jump through a few of those that have grams and moles, or liters and moles, and pick a few of those just to try and see if you can get a conversion figured out. Should have an answer key around for you to look at either today or next day that we're together in class, and you can see how you did with those. But try a few, and after you've done a few, find someone near you who's tried the same ones and see if you've gotten similar answers or if you're way off. One of you might be really right, can help the other out, and if you're both right, great. If you're both wrong, well, maybe find a third person to help you out, and I'll talk to you as soon as I see you again.